Alright, y'all. So, working through this worksheet. So first thing we start off to is just getting a better handle on mutually exclusive versus overlapping. Remember, mutually exclusive is whenever you don't have any overlap, and overlapping is when you do have overlap, right? And so, can you run and swim at the same time? No, you can't. They're mutually exclusive. Can we blonde and male at the same time? I would hope so. They are overlapping. Can you roll a 5 and a 6 at the same time with one single die? No, you can't, because you either land on 5 or you land on 6. So those are mutually exclusive. Can you make an A and a B at the same time for your final exam? No. You're either going to make an A or a B, or hopefully an A or B. So it's mutually exclusive. Can it be sunny and raining at the same time? I've seen it. Maybe you haven't. I'm going to say it's overlapping. If you're like, what? I've never seen that before. Whatever. As long as you know the reason you're choosing is you're like, those can't both happen at the same time. I say they can. Alright, next thing we're looking at is these formulas, okay? Because this is what we do whenever they're mutually exclusive. We just add the probabilities together, okay? When they overlap, then we have to subtract out the part that overlaps, okay? So, if they're mutually exclusive, that means the part that overlaps is 0. And so if you want, you can just always use this formula and just subtract out 0 at the end. Or you can make sure you're using the right one. But those are two formulas. I would write those down if you haven't already. Kind of important. Cool. Moving on. So, we got a die. Alright, we're rolling a die. You were looking at what's the probability roll, a 5 or a 6. Okay? Once again, we said up top, you can't roll a 5 and a 6 at the same time. So, we're going to say the probability we roll a 5. So probability 5 or 6 could be the probability roll a 5 plus the probability roll a 6. Okay? There are 6 total options. One of them is a 5. So the probability roll a 5 is 1 out of 6. Probability roll a 6 is also 1 out of 6. When you do that, you get 2 out of 6 or 1 out of 3, which is 0.33 repeating. Okay? So there's your probability of rolling a 5 or a 6. It's a 1 in 3 chance. It's 0.33, 33%. Okay? Cool. Next one. We're looking at factors of 12 or even. Okay? Factors of 12 or even. So going through, I'm first going to list all the factors of 12. So my factors of 12, remember factors are anything that you can multiply with something else to get 12. So it's 1, write it as a set, it's 1, 2, 3, 4, 6. None of the others can be multiplied together to get 12. Okay? Then we look at the even numbers. Even numbers, of course, are 2, 4, 6, 8, and 10. So then what we want to look at are the ones that are factor of 12s and even numbers. Okay? So factors and evens. Okay? Those are the ones that are in both. You can also think of that as factor intersect even. So that's a 2, a 4, and a 6. You see how the 2, 4, and 6 are in both of these groups? 2, 4, 6. So, when we're doing this probability, we're doing the probability of factor 12 or even. Okay? So, with this equation we see up here, we're going to do the probability factor of 12 plus the probability it's even minus the both. The probability they're both. Okay? And so, I think the easiest way to do this is just to count the total and get the total number that apply to this type of thing and then divide it by our full sample space. Okay? And so when I'm doing this, we're going to have F plus E plus F intersect minus F intersect E. Right? And so going through, we have 5 that are a factor of 12. We have 5 that are even. And 3 that intersect. Okay, so 5 plus 5 minus 3 equals 7. And then we're going to divide by the total number of options. Okay, there are 10 things in the spinner, so we're going to divide that by 10, which gives us 0.7. And that's our answer. And so what we were doing when we went through is we just made sure we number that were factors, number that were even, subtract out the ones that were both. Alright? Cool, moving on. So this one I'm going to use the Venn diagram to see if that helps us. If it doesn't, just ignore it. Just don't. But if it helps you, awesome. So, when filling out a Venn diagram, well, first of all, let's look at our problem. So we got girls or bees, alright? So one side will be girl, the other side will be gets a bee. Okay? So, let's see if I can make this a little clearer. Alright, hopefully that's a little clearer. But okay, so when I'm looking at this, when I'm filling out a Venn diagram, I'm going to start from the middle and work my way out. Okay? So the first thing I'm going to look at is how many are both a girl and got a B. Okay, so there's 9 boys and 11 girls in class. Final exam, 4 of the boys got a B and 5 of the girls got a B. So there's 5 people who were girls who got a B. So I'm going to put my 5 in the middle here. Alright? From there, I'm going to go to the girls' side. Okay? So how many total girls were there? There were 11 total girls. Okay? But we already have 5 of them. So the amount that were girls, that are only girls and didn't get a B, would be 11 minus 5, or 6. Now I'm going to do the same thing for the other side. So 5 girls got a B, plus another 4 boys. So those 4 boys were the group that got a B that weren't girls. And so this side is going to be 4. Okay? And then I can fill out my sample space. My total number of students overall is 20. Right? Okay. Well, we're looking at the people who didn't get a B and were not a girl. So we're looking at the boys who didn't get a B. So there's 9 boys. Okay. 4 of them got a B, which means 5 of them didn't. So there are 5 people on the outside. Alright. Cool. So then from here, we just got to fill in our formula. So probability of girl or got a B would be probability of girl plus probability of B minus probability of girl intersect B. So probability of the girl, there were 11 total girls. That's what we see there, and that's what we see right here. So 11 boys. There were there were B's. That B stands for B's, not boys. B's. There were 9 total B's, 4 plus 5, or 4 plus 5, plus 9 B's, minus those were both. So there were 5 girls who got a B. So you got to take that out. Okay, when you do that, you get 15. Then we divide by the total number of people. There are 9 boys and 11 girls. 9 plus 11 makes 20. So that's 0.75. Cool. Moving on. This one I'm not going to do with a Venn diagram because, yeah, I'm just not going to. Okay. So, triangle or square. Probability of a triangle or square. So looking at it, we can see that there are 10 total shapes. Okay. The probability of triangle, there were 4 triangles. Right? 1, 2, 3, 4. 1, 2, 3, 4. Plus 4 squares. 1, 2, 3, 4 squares. Okay. We know there's no overlap, so we don't have to subtract anything else out. So that gives us 8. total things that meet our condition. We're going to divide that by the total number of objects, 10, which is 0.8. Cool. Moving on. So, this one's a little bit tricky. If you can do it without the Venn diagram, great. If you need the Venn diagram, great. So, I'm going to do the Venn diagram again. So we're looking at right-handed people, right-handed or dog. Okay, right-handed dog, R&D. So, once again, we start from the middle. Okay? So, if we read this out, there are 34 people who are right-handed and 6 people who are left-handed. Of the 13 people who have a dog, 8 are right-handed. So 8 people are right-handed and have a dog. So we're going to put that in the middle. I'm working my way backwards. Of the 13 people who have a dog, 8 are right-handed, which means 13 of them, 13 total people with dogs, minus 8 that are right-handed. That means there's 5 people with dogs that are not right-handed. Right? Then we keep moving back, 6 people left-handed, blah, 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 blah. 34 people who are right-handed. But of those 34 people that are right-handed, 8 of them have a dog, right? So we got to do 34 minus 8 to give us our 26. Okay? And then the final thing is the people who are left-handed and don't have a dog. Okay, so there's 6 left-handed people. 5 of them have a dog. I know that because there's the dog people that are left-handed. There's a dog people who are left-handed because they're not right-handed, and so we have a 1 out here. Okay. Cool. So probably right-handed or dog. All right. So we're gonna do right hand plus dog minus right hand intersect dog. Okay. So 34 people right-handed. Of the 13 people who have a dog, so 13 dogs, we're going to subtract out the number who are right-handed and have a dog, which would be 8. When we do that, we get 39. 34 plus 13 minus 8 equals 39. There are 34 right-handed people and 6 left-handed people, so 34 plus 6 gives us 40 total people, so 39 over 40. Okay. Alright, 39 over 40 gives us 0.975. And that's our answer, 0.975. Moving right along. So probably triangle or shaded. So I'm looking at my triangles plus my shadeds. Okay, then I'm going to subtract out triangle and shaded. Alright, so I have 1, 2, 3, 4, 5, 6, 7, 8 triangles. I have 1, 2, 3, 4, 5, 6, 7 shaded figures. I'll subtract out the ones that are both triangles and shaded, which would be 4. That gives me 11. 11 meet our condition. Out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 total items. 11 out of 14 is 0.786. Just count the number of triangles, count the number of shaded figures, subtracted out the ones that were triangles and shaded. Cool. This next one's fun because it has 2 of them in one. So, of these 10 numbers here, we're going to have the multiples of 6, plus primes, subtract out the multiples of 6, intersect prime. So our multiples of 6 here are just 6. So there's only one of them. Our prime numbers, remember those are prime numbers or anything that can't be multiplied to get something, only itself and 1 are factors. So our prime number is 2, 3, 5, and 7. So 1, 2, 3, 4 different prime numbers. And then there's nothing that is both a prime number and a multiple of 6. So that gives us a full 5 out of 10, which gives us 0.5. So you have a 0.5 probability of pulling a multiple 6 or a prime number. Well, for the multiple 3s, we got M3 plus even minus M3 intersect even. Okay. The multiples 3s are 3, 6, 9, so there's 3 of them. The even numbers are 2, 4, 6, 8, 10, or 5 of them. Subtract out, there is one number that is both a multiple of 3 and even. That would be 6. So we're going to subtract out 1. So that gives us 7 divided by 10 gives us 0.7. Cool. Moving on to number 6. We got 400 college students, 120 are enrolled in math, 22 are enrolled in English, and 55 are enrolled in both. Okay? So we're doing math plus English minus math intersect English. Okay? So the ones enrolled in math, there's 120 enrolled in math. There's 220 enrolled in English. And then there's 55 that enrolled in both. Okay, so 120 plus 220 minus 55 gives us 285. And that's out of the 400 students, so we divide by 400. So 285 divided by 400 gives us 0.7125. Cool. Moving on to these back. The back, we start to have some fun with cards and stuff. So, standard deck of cards. We got 52 cards, 13 of each suit, 26 of each color, 4 of each number. So, probability of a spade. Okay, once again, there's 13 of each thing. You can count them: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 10, jack, king, queen. 10, queen, king, excuse me. Anyways, 13 total spades divided by the 52 total cards gives us a 1 and 4, which gives us 0.25. Probably just a 5 of diamonds. Just the 5 of diamonds. How many 5s of diamonds do we see? It's just one. It's just this 5 right here. Okay? So that's going to be 1, 5 of diamonds, divided by our 52 total cards, which will give us our 0.019 probability. Okay. Moving on, face cards. Once again, face cards are just the ones that aren't numbers. They're the jack, king, queen. And so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 face cards, divided by 52 total cards. 12 divided by 52 gives us 0.23. Alright. Probability of king. There are 1, 2, 3, 4 kings. Once again, out of 52 gives us 0.077. Probability of red. Half the cards are red, half the cards are not. So there's hearts and diamonds are red. So there's 26 total red cards divided by the 52 total, which, like I said, is the 1/2. 1/2 gives us 0.5. Final one is probability of getting a heart. This is the exact same thing as the probability of getting a spade. Okay, so there's 13 total hearts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 total hearts divided by 52 total cards gives us 1 out of 4, which is 0.25. Cool. Still chugging along. So, coming and looking at these, there once again we're just counting up the total number of possibilities. Okay, so the probability of being a queen, okay, is 1, 2, 3, 4. Well, there's 4 queens, I mean. Plus 7s. There's 1, 2, 3, 4, 7. Okay, and there's none that are both, so we don't have to subtract any out. That gives us 8 out of 52. 8 out of 52 is 0.154. Queen or red. So once again, there are 4 queens, right? There are 26 red cards, because there are 26, two suits of 13. Okay. And then, but there's 2 queens here that are also red. So you have to subtract out 2. So that gives us 28 divided by our 52. 28 divided by 52 is 0.538. Yeah, 0.538. Club or red. Okay. Clubs. There are 13 clubs. They're over here. Okay. And then there are 26 red cards. And there are no cards that are both red and clubs. Here are all the red cards. Those are all the club cards. So that gives us 13 plus 26 is 39 out of 52. 39 divided by 52 is 0.75. Awesome. Diamond or heart. There are 13 diamonds. Right here, 13 diamonds. There are 13 hearts. This is 26 out of 52, which is 0.5. Face card or diamond. Okay, once again, the face cards are the jack, queen, and king. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 face cards. 12 face cards. Okay. Plus there are 13 diamonds. Okay. But there are 3 face cards that are also diamonds. So you have to subtract out the 3. So that gives us 22, I believe. 22 out of 52, which is 0.423. Black or 2. Okay. Half the deck is black, so that's 26 black cards. Okay. So there are 4 2s, but once again we got to check. There are 2 cards that are both black and 2s. So you got to subtract out the 2 cards that are both black and 2. So that gives us 28 out of 52. 28 out of 52 is 0.538. Cool. Moving on. Number 13. We got a table here. The table shows us we have how many males and females we have and how many genes or not genes we have. Alright, and it gives us our totals. So probably a female or wear genes. Alright, so if you look at the female, that's this line right here. There are 19 total females, right? Wearing jeans, that's this column right here, plus the 20 people wearing jeans. But there's 8 people who are both jeans and female wearing. Okay? So that gives us 19 plus 20 minus 8 gives us 31 total people who are either female or wore jeans. We divide that by the 36 total that we have down here. 31 divided by 36 gives us 0.861. That's how we do that one. Moving on. Word problems. This word gets fun. So, with these, alright, so we're looking at a math class of 30 students, okay? 17 are boys, 13 are girls. On each test, 4 boys and 5 girls in the A. If a student is chosen at random from the class, what is the probability of choosing a girl or an A student? So probability of girl or A. Okay? That's the same. Oh my goodness, what am I doing? I'm so sorry, y'all. That's the same as the probability of girl union A. Okay? So, that's going to be girls plus A's minus both. Alright? So, looking at the number of girls, we have 13 girls. 13 girls. Plus number of A's. We had 5 girls and 4 boys make an A, so that's 9 total A's. Minus both, there were 5 girls that made an A. So minus 5. That's going to give us 22 minus 5. 13 plus 9 minus 5 is 17. 17 divided by 30 is 0.57. Alright, that was a lot like the ones we had before. Alright, 15. On New Year's Eve, the probability of a person having a car accident is 0.09. The probability of a person driving while intoxicated is 0.32. And the probability of a person having an accident while intoxicated is 0.15. What is the probability of driving intoxicated while or having a car accident? So probability of intoxicated plus car accident. Okay? That's going to be or, excuse me. That should be an or here. That's probability of intoxicated plus probability of car minus probability of intoxicated intersect car. Okay? So probability of being intoxicated is 0.32. Probability of having a car accident is 0.15. Minus probability of being intoxicated and having an accident is 0.09. Okay? So 0.32 plus 0.15 minus 0.09. That gives us 0.38. Alright, because everything was already in probabilities, we don't have to divide by anything. Because it's already the probability, that's already the probability, that's already the probability. So this one just gets to stay as 0.38, and that's our answer. Number 16, we're going through, find the probability that Ted or Janet are employed. So a survey of couples in a city found the following probabilities. Probably the husband is employed as 0.85, probably the wife is employed as 0.60, probably that both employed as 0.55. So, we're going to the probability of husband or wife employed. So that's probability of husband plus probability of wife minus probability of husband intersect wife. So probability of husband is 0.85. Probability of wife is 0.6. Probability that both are employed is 0.55. When you do that, you get 0.85 plus 0.6 minus 0.55, 0.9. Once again, that can just be our answer because it is already in probabilities. Alright. A sample of automobiles dealerships found that 19% of the automobiles sold are silver, 22% are sold as SUVs, 16% of automobiles are silver SUVs. Are the two events mutually exclusive? No, they're not mutually exclusive because there is some that have both. So no, it's not mutually exclusive based on that sentence right there. No. Huh. Alright, they're not mutually exclusive. So what's the probability that random chosen sold automobile is silver or SUV? So probability of silver union SUV. So that would be probability of silver plus probability of SUV minus probability of silver intersect SUV. Okay, probability of silver is probability of SUV minus probability of silver intersect the SUV. Probability of silver is 19% or 0.19. Probability of SUV is 22% or 0.22. Probability of both is 16% or 0.16. And that gives us 0.25 as our final answer. So, last but not least, swimming. We all know that's important. So, swimming, probability of swim or whistle is going to be probability of swim plus probability of whistle minus probability of swim intersect whistle. So, probability of swimming is 80% or 0.8. Probability of whistle is 70% or 0.7 minus probability of both, which is 0.55. And that gives us, I believe, 0.95. Wait, let me check that. 0.8 plus 0.7 minus 0.55. Yeah, 0.95. And that's it. So, just the most important thing we're doing this is just find out the two things. Probability of one plus the probability of the other minus the both. And when you're doing them where you have to add them up, you can divide by 50 at each step, or you can just divide by, I guess that's a 30. You divide by 30 at each step, you can just divide by 30 at the end. Or, yeah. See you tomorrow. Hopefully tomorrow we feel good about this.